All right, today we will be covering slope fields. And Euler's method. We're going to start off with an example. We're going to use integration to find a general solution of the differential equation. So on this, what we're going to be doing here is you're basically going to be taking the antiderivative. Now, I need to move this dx over here before I throw in the integral. So I'm going to multiply both sides by dx. So if I multiply this side by dx, I'm left with a dy equals 10x to the fourth minus 2x cubed times dx. I'm now going to get rid of my derivative. So I'm going to take the antiderivative of both sides. Now the antiderivative of dy is just a y. The antiderivative here is going to be a 10x. I'm going to add 1 to the exponent, whatever the exponent is, I'm going to divide by it. 2x, I'm going to add 1 to the exponent, whatever the exponent is, I'm going to divide by it. And then because I didn't give you the upper and the lower bound, don't forget you have this plus c. So the final answer here is going to be a 2x to the fifth minus x to the fourth divided by 2 plus c. We're using integration to generate a general solution of the differential equation. So you're basically just taking the antiderivative. I can't take the antiderivative yet. That dx needs to be over here. So I'm going to multiply both sides by dx. So dy equals x cosine x squared times dx. I'm now going to take the antiderivative of both sides. Antiderivative of dy is just y. However, on this side, if you notice, it says x times cosine x squared. You have to use u substitution here. Now I'm going to let u equal the argument. The argument is the x squared. I need to find out what dx is. So the derivative of u is going to be a du. The derivative of x squared is going to be a 2x dx. Since I'm solving for dx, I'm going to divide both sides by 2x. So then du over 2x equals dx. So let me rewrite this. This is going to be an x cosine of u times du over 2x, which is going to work out nicely because now the x's can cancel each other out. That 2 is a constant, so I'm going to throw the 2 out in the front. So this is going to be a 1/2 antiderivative of cosine of u du. Now you can go ahead and in the antiderivative of cosine u is just sine u. So now that I'm taking the antiderivative, I no longer write the integral in the du. That is going to be a sine u. And because I didn't give you the upper and lower bound, don't forget the plus c. Now you are not done because our problem did not have u's, it had x's. So make sure you plug the u back in. So then y equals 1/2 sine of x squared plus c. Next, we're going to get into slope fields. A slope field or a directional field are line segments with slope f of xy if the derivative is equal to the f of xy at selected points x and y. Basically, each point on the graph is going to have some type of slope. So we're going to sketch a slope field for the differential equation y prime equals x minus y for the points negative 1, 1, 0, 1, and 1, 1. So the first thing you have to do is plug in the point into the derivative. So first we are going to plug the point into to find the y prime. We'll say plug the point in. So for the first point, we have a negative 1, 1. So the x is going to be the negative 1. The y is going to be a positive 1. So y prime is equal to the x, which is a negative 1 minus a 1. So the y prime equals a negative 2. If this is our graph right here, here's the negative 1, 1. So basically at this point, I want a slope of negative 2, meaning you're going to go down 2 over 1. So because it's going down 2 over 1, you see this angle? The angle has to look like this. So that's what it means. So here's the point, negative 1, positive 1. It's right there. And I want the slope to be a negative 2. So the slope would be down 2 over 1. So it would end right here. So that's why I'm drawing that slope. So that slope right there is going to be the negative 2. So at that point on the graph, sketch the slope. So now the next point is going to be 0, 1, which is right here. So here's 0, 1. I need to find out what the slope is. So y prime equals x is 0 minus 1. So y prime equals a negative 1. So negative 1 would mean down 1 over 1. So it's going to look like a slope like this. Not as steep as this one. Not as steep as this one, because that's a slope of negative 2. This is a slope of negative 1. And the last one I'm going to plug in is the 0.11, which is right here. So this is y prime equals 1 minus 1, which y prime equals a 0. Well, a slope of 0 is a horizontal line. So this is a slope field. You're drawing slopes at each individual point. You're drawing slopes at each individual point. We are going to sketch a slope field for the differential equation y prime equals 2x plus y. We're going to use the slope field to sketch the solution that passes through the point 1, 1. So we're going to sketch a slope field with the differential equation. So there's the equation. The derivative equation is going to be 2x plus y. So all of the points you have to plug in the 2x plus y to find out what the derivative is. And then we're going to use the slope field to sketch the solution that passes through the point 1, 1. So I'm going to make a table. And then these are going to be all the slopes. I'm definitely going to plug in a -2, -1, and -2, 1, -1, -1, -1, +1, 0, -1, 0, 1, 1, -1, 1, 1, 2, -1, and 2, 1. So let's find out our first one right here. So this y prime is equal to 2. The x in this case is a -2. The y is a -1. So this comes out to be y prime equals -4 minus 1. So y prime equals -5. So what that tells me is that at the point -2, -1, because that's the coordinate, at the point -2, -1, you want to sketch a slope of -5. Sketch a slope of -5. So at the point x is -2, y is -1, which is right here. Now a slope of -5 just means it's going to be really steep like this. That's a slope of -5. Let's find out the next one is. Y prime is equal to, the x in this case is going to be the -2, the y is going to be the 1. So this is 2 times -2 plus 1. So that's going to be a -4 plus 1, which is a -3. So now what this says is at the point -2 positive 1, I want to sketch a slope of -3. So let me look for that point. -2 positive 1. Oh, I messed up. -2 -1 is down here. -2 -1 is down here. That slope is a -5. Now I have the point -2 -1. So here's -2 positive 1. And that slope is a -3. So it's not as steep as this one is, because that's a slope of -5, meaning it's going to go down 5 over 1, where this one is going to be down 3 over 1. Right here, y prime equals 2 times the x is a -1 minus the y, which is a -1. That comes out to be a -3. So at that point, at the point -1, -1, or no, -1, positive 1, I want a slope of -3, which is actually the same as this one. So these two have to be looking the same, meaning you're going to go down 3, 1, 2, 3 over 1, and then draw that line. When I plug in a -1 here, 2 times -1 plus 1, that's going to give me a -1 answer. So at the coordinate -1, oh, I did it again. -1, -1 was down here. That's a -3. Sorry. And then right here, I have a -1, +1, and that slope is going to be a -1. So that means go down 1 over 1. So make sure you're graphing at the right point because I made that mistake twice already. So at this point, look at -2, -1. This slope is a -5, meaning it went down 5 over 1. At this point, -2, +1, the slope is -3. So -1, -2, -3 over 1. So this slope is a -3. This slope was a -5. At the point -1, -1, the slope was a -3. Here I have a -1, +1. The slope is a -1. Now when I plug in 0, that's 0 minus 1, which is a -1. So at the point 0, -1. So here's the point, x is 0, y is -1. It's going to be a -1, which means down 1 over 1. That's why it's looking like that. Now I have a 0, 1. So when I plug in 0, 1, I'm left with a 1. So now it's actually going to go up. So as 0, 1, it's going to go up 1 over 1. So it's going to look like this. These are called slope fields. You're finding the slope at each individual point. Right here, when I plug in 1, 2 times 1 is 2 minus 1. That comes out to be a 1. So at the point x is 1, y is -1 right here. I want a slope of 1. So that means I go up 1 over 1. That's why it's looking like that. When I plug in 1 here, 1 times 2 is 2 plus 1 is 3. So at the point x is 1, y is 1, I want a slope of 3, which means it's going to go up 3. So 1, 2, 3 over 1. So it's coming at that angle. When I plug in 2 here, 2 times 2 is 4, minus 1 is 3. So at the point x is 2, y is -1, it's right here. I want a slope of 3. So it's going to go up 3, 1, 2, 3 over 1. So there's my slope. And then the last one, when I plug in a 2, 2 times 2 is 4, plus 1 is 5. So here x is 2, y is 1. So it's talking about that point. Now I want a slope of 5. So it's going to go up 1, 2, 3, 4, 5 over 1. So there's my slope right there. Now, if you want a better look at this, we're going to sketch a little bit more. We're going to sketch more points for a better slope field. That way you can tell the slope field passing through 1, 1. Because right now, here's 1, 1. I can't tell. Obviously, it's going down and then it's going up, as you can see. So I'm going to graph a couple more. So if I plug in -2, -2, I end up getting a -6. Let me graph all these. So at -2, -1, it was a -5 slope. At -2, +1, it was a -3 slope. At -1, -1, it was a -3 slope. At -1, +1, it was a -1 slope. At 0, -1, it's a -1 slope, which means down 1 over 1. So that's why it's going like that. At 0, 1, it's a +1 slope. So up 1 over 1. At 1, -1, it's a 1 slope. At 1 positive 1, it's a 3 slope, so it starts going steeper. And then at 2 negative 1, it was a positive 3, and then it goes positive 5. So here at negative 2, which is right here, it's a negative 6, so it's even steeper. And then when I plug in negative 2, 2, I get a negative 2. So that one's just a little bit more there. Actually less, because that was a 3. And then when I plug in negative 1, negative 2, that's going to be a negative 4. So at negative 1, negative 2, it's going to be a negative 4. So that'd be like a down 4 over 1. Negative 1, negative 2 is going to be a 0. So at negative 1, negative 1, negative 2. Oh, wait. Let me see. 2 times, that's negative 2. Negative 2 plus 2, that's a 0. That's negative 2. Oh, negative 2 minus 2 is negative 4. Why did I do this? Oh, this should have been a positive 2. So then right here, negative 1 times 2 is negative 2 plus 2, that's a 0. So then right here at negative 1, positive 2, that's a 0. When I plug in 0 here, that's going to be a negative 2. So at 0, negative 2 is going to be negative 2. At 0, positive 2, that's going to be a positive 2. 1, negative 2, that's going to be 2 minus 2, which is a 0. Sorry. All right. So now here, when I plug in 1, 2, so I plug in, that's 2 plus 2, which is going to be a 4. So at x is 1, y is 2, I need a 4. Oh, I didn't graph this one. Now that one's going to be 0. At 1, negative 2, that's a 0. Now right here, when I plug in 2, negative 2, I get a positive 2. So 2, negative 2, I get a positive 2. Then 2, negative 2 gives me a positive 2. So now you're doing the flow. So it's set at the point 1, 1. So here's the point 1, 1 right here. You need to sketch the solution that passes 1, 1. So go with the flow. So as you notice, it goes like this. It's going like this. So I'm just going to kind of sketch it like this. You're definitely going to want that. The slope right there is going to pay some type of influence on it. And as you can see, look at all these are negative. And then what happens? They all come out to be positive. They're like moving up.